So this is the week 3 material. We're going over chapter 6 on metric and household measurements. We're going to see how to do our conversions. So the first thing we want to look at is our metric units. In the metric system, there are 3 basic units of measurement, one for weight, one for volume, and one for length. Weight, which we use to measure solid medications or measure body weight, is based on the gram. The abbreviations for gram are G or GM, and usually we use G. I've not seen GM used. For volume, meaning liquid measurements, we use the liter and variations of the liter. The abbreviation for the liter is capital L. And for measuring length, body parts, body wounds, the height of a person, we use the meter and variations of the meter. Abbreviation for meter is lowercase m. So I call this my metric number line, and we will talk about how to use this in conversions in a bit. So I wanted to show you where your basic units lie. This base unit, these are your gram, your meter, and your liter. And then when I said variations of each, they have prefixes. Kilo, this would be kilogram, kilometer, kiloliter. Centi is used only with meter in this class, so centimeter would be abbreviated cm. Milli is used milligram, millimeter, milliliter, and micro is the abbreviation for micro, notice, is MC because M was already used for milli. So microgram, micrometer, microliter. So this chart again shows you your basic units are right here, and then your kilo prefix, your milli prefix, your centi prefix, and your micro prefix. So when I said these are variations of the basic unit, these are multiples of the basic unit. So when we talked about multiplying and dividing by multiples of 10, conversions in the metric system is where that's going to come in handy. So in the metric system, each of these lines, the big lines and the little lines, represent 1 decimal point. So when you're converting within the metric system, say we're converting some number of kilograms to grams. So if I had, say, 2.5 kilograms and I wanted to convert it to grams, well, this is saying I'd have to go to the right 1, 2, 3 decimal places. So 2.5, and I go to the right 1, 2, 3. Your point would be right here. So 2.5 kilograms is equivalent to 2,500 grams. If I had, say, 500 milliliters, and I wanted to convert that to liters. Well, milliliter is on this line, and liter is back here. It's 1, 2, 3 decimal places to the left. So 500 milliliters, remember the decimal is behind the last zero. If I go 1, 2, 3 decimal places to the left, the decimal is now in front of the 5. So that's 0.5 liters. So remember, each decimal place represents 10. So 3 decimal places is 10 times 10 times 10, which is 1,000. So to go from the kilo prefix to a basic unit, you're multiplying by 1,000. To go from basic units to the milli prefix, you multiply by 1,000. To go from the milli to the micro, you multiply by 1,000. If you're going in the other direction, you would divide by 1,000. So all these different prefixes back and forth is 1,000. The only one that's different is centi. Remember, each one of these is one decimal, which represents a multiple of 10. So if I'm going from meter, basic unit, to centimeter, 10 times 10 is 100. So 1 meter would be equivalent to 100 centimeters. If I'm going from centimeter to millimeter, that's 10. So 1 centimeter is 10 millimeters. So we'll talk about conversions more in a minute. I wanted to give you the rules on metric notation. So when we are writing numbers in the metric system, we use decimals. We do not use fractions. We've already talked, you need the leading zero always, and you leave off any trailing zeros. The metric unit or label or abbreviation, whatever you want to call it, comes after the number, not before. And there's always a one space between the number and the label. So you would write 40 space and milligram rather than putting the milligram in front or not leaving a space. And for your abbreviations, everything is lowercase except L. L is always capitalized because a lowercase l looks too much like a 1. And that is one of those medical error prevention techniques. So a lowercase l looks too much like a 1 anytime you're using L for milliliter. For liter, milliliter, microliter, kiloliter, you always use capital L. Okay, so this next slide kind of maps out exactly what I was saying about converting within the metric system. So for the major, I call these jumps, from the kilo to the base, base to milli, milli to micro, micro to milli to base. These I call your major jumps. Each of these is 3 decimal places. So if you're going to the right, you multiply by 1,000, which is the same as moving your decimal point to the right 3 places. If you're going to the left, you divide by 1,000, which is the same as 3 decimal places to the left. So the only one that is not 3 places is centi. If you're going from the base unit to centi, it's only 100 or 2 places. If you're going from centi to milli, it's only 10 or 1 place. So remember, if you're going to the right, you're multiplying, but if you're going to the left, you would divide. Okay, so looking at these, we'll do each of these one at a time. Okay, so we have 453 grams. Gram is your basic unit, so it would be right here. 453. And we're going to kilogram. So kilogram is 1, 2, 3 places to the left. 1, 2, 3. So that would be 0.453 kilograms. Or if you don't like the jumping spaces, you take 453, divide by 1,000 with your calculator, and you'll get 0.453. So 1.4 liters. Let's see, liter is a basic unit, so that is right here in the middle. So if we have 1.4 liters and we're going to milliliter, which milliliter is over here, 3 spaces away. So 1.4, and if we're going 1, 2, 3, that would give us 1,400 milliliters. Or you could take 1.4 and multiply by 1,000, which still gives you your 1,400 milliliters. Milligrams. That's right here. So we have 7 milligrams. And we're going to micrograms. So that is 1, 2, 3 to the right. 7. Remember, the decimal is here after the 7. We go 1, 2, 3 to the right. We have 7,000 micrograms. Or think about it as multiplying 7 by 1,000. 37 micrograms, back to milligrams. So 37 micrograms is here. We're going back to milligrams, which is 3 places. 1, 2, 3. So that would be 0.037 milligrams. Now going from grams to micrograms. So gram is a basic unit right here in the middle. 2.6 grams, and we're going all the way to micrograms. So that is 6 decimal places. 2.6, 1, 2, 3, 4, 5, 6. So we need all these zeros, and your decimal point would be here. So that's 2,600,000 micrograms. That is equivalent to multiplying by 1,000 and then by another 1,000. So 1,000 times 1,000 is 1,000,000. So you can either multiply by 1,000 twice or just multiply by 1,000,000. Milliliters to liters. So milliliters is right here. So we have 200 milliliters. Decimal point is right here. We're going back to liter, 3 places. 0.2 liters. Or you can think of it as 200 divided by 1,000. Then meter to centimeter. Meter is right here. 1 meter is a basic unit. Now remember, centimeter is only 2 decimal places away. So 1, 2, 100 centimeters. So 1 meter is 100 centimeters. Whoops. Or you can think of it as multiplying your 1 times 100. Okay, so each of these lines is 1 decimal place. Or you could think of it as multiplying by 10. So when you're going from kilo to base, you're multiplying by 10, by 10, by 10. That's 10 times 10 times 10. That's why the whole jump itself is multiplying by 1,000. Okay, so the next thing we're going to look at is a couple of other methods of doing exactly what we just did. We have dimensional analysis method and proportion method. So I'm going to show you how each of these works. So the dimensional analysis method and the proportion method, you have to memorize your conversions. So the number line can actually help you with that as well. So we said each of these big jumps is 1,000. So 1 kilogram would be 1,000 grams. 1 kilo of any of these, kilogram, kilometer, kiloliter, equals 1,000 grams, meters, or liters. So 1 kilo is 1,000 of the base unit. So 1 kilogram is 1,000 grams. 1 kilometer is 1,000 meters. 1 kiloliter is 1,000 liters. Then one of your base unit would be 1,000 of the millis. So 1 gram is 1,000 milligrams. 1 meter is 1,000 millimeters. 1 liter is 1,000 milliliters. And then 1 milli would be 1,000 micros. 1 milligram is 1,000 microgram. 1 millimeter is 1,000 micrometers. 1 milliliter is 1,000 microliters. So these are all, I call them equivalencies. We can do the centimeter too. 1 meter is 100 centimeters. 1 centimeter is 10 millimeters. So all of these equivalencies, you can either memorize them or derive them from the number line itself. But the thing about these equivalencies is they each produce two different conversion factors. The fact that we know 1 gram equals 1,000 milligrams. That's an equivalency. This produces two different conversion factors, two different ratios, if you will. 1 gram is to 1,000 milligrams. That's one ratio that can be derived from this equivalency. And we call that ratio a conversion factor. It's used to do conversions. Or we can write it upside down. 1,000 milligrams equals 1 gram, right? They mean the same thing. Either way, 1 gram is 1,000 milligrams. So how do we use conversion factors to do conversions? If, say, we started with whatever you are converting, you multiply it by a conversion factor. Okay, so if we have some number of grams, 0.02 grams, and we want to convert that, say we have 0.02 grams, and we want to know how many milligrams does that equal? Well, to do it the dimensional analysis way, you're going to take your 0.02 grams. You can leave it or put it over 1. Either way, you understand it's a numerator and the denominator is 1. And then you multiply it by a conversion factor. Which one of these do I use? Well, you use the one that has milligrams on top. You are going from grams to milligrams. So you want the milligrams on top so that the label or the unit gram cancels. So then we multiply across the top 0.02 times 1,000 milligrams and over 1 times 1 basically. So then 0.02 times 1,000 is 20. So 20 over 1 milligrams, which is just 20 milligrams. So whatever you're converting, you multiply it by the conversion factor that has the unit you are converting to on top. Say we had milligrams. Say we have 3,421.02 milligrams. And I want to know how many grams that is. So I take my 3,421.02 milligrams over 1, multiply it by the conversion factor now that has the milligram on the bottom and the gram on top. 1 gram is 1,000 milligrams. So your milligram label unit abbreviation cancels. And you have 3,421.02 times 1 grams over 1 times 1,000, which gives you 1,000. Now you do this division. 3,421.02 divided by 1,000 is 3.42102 grams. So for dimensional analysis, you take whatever you have, multiply it by the conversion factor. You just have to remember the unit you're converting to goes on top, and the unit you're converting from goes on the bottom. So that is the dimensional analysis method. So we had our number line method, we have our dimensional analysis method, and the third method is the proportion method. So with the proportion method, we still have to remember our equivalencies, all these equivalencies. So let's take the first one again. We had 0.02 grams, we're converting to milligrams. 0.02 grams is how many milligrams? Well, this is a ratio. We can set it up as 0.02 grams is to how many milligrams. And in a proportion, we set it equal to another ratio where the units match across the top and bottom. So remember, with a proportion, the units match on top and bottom. But with dimensional analysis, they don't. So 1 gram is 1,000 milligrams. That's your other ratio, your conversion factor. That's your other ratio. Just remember, the units match horizontally. In a proportion. So do not get your proportions confused with multiplying fractions. Remember, multiplying fractions, you multiply across the top and then across the bottom. But with a proportion, we cross multiply. Cross multiply, think of it as diagonal multiply. So we would take the 0.02 times 1,000 and divide by 1. And when you're doing it proportion way, you disregard your units because you know what unit you're looking for. 0.02 times 1,000 gives me 20. 20 divided by 1 is still 20. And we know we're looking for milligrams. So 0.02 grams equals 20 milligrams. So you have 3 different methods. You have your number line method, you have your dimensional analysis method, which involves multiplying fractions. Multiplying fractions, you multiply straight across the top, straight across the bottom, and if you end up with a fraction, then you divide here. Then the proportion method, you set up your 2 ratios, equal sign between them, units match across the top and bottom. Cross multiply and divide. So with dimensional analysis, your units are actually on opposite sides of the fraction bar so they can cancel. But in proportion, your units are on the same side of the fraction bar. Okay, so that is what these next couple of slides talk about. Dimensional analysis method and the proportion method. And there's a couple of examples. So with the proportion method, this slide just showing you it can be done 4 different ways. As long as your units match across the top and the bottom, your proportion can be set up 4 different ways. But you're still multiplying the same 2 numbers in all 4 ways. So the next thing is household measurements. So metric, we can use the number line to convert within the metric system. That means from metric to metric. Now the household system of measurement, we can't use any fancy number line because we're going to be converting from household measurements to metric measurements. So we're not staying in the same form of measurement. So household is what we normally use. In metric, you saw we had weight was gram, volume was liter, and length was meter. Well, in the household measurements, when we measure weight, it's usually in pounds or pounds and ounces. The volume can be cups, quarts, pints, teaspoons, tablespoons, ounces. And length, we usually measure in feet and inches. So converting between the two systems of measurement, between metric and our household, we can use the ratio and proportion method. Again, we can use dimensional analysis method again, or we can use this, I don't know, I call it like my multiply divide method, which it's not my method, it's just the way I do it, and I'm sure many other people before me did it that way. But all the methods, to use all the methods, you have to memorize all the conversions on your sheet. All these equalities are equivalences. Each one of these will give you 2 conversion factors. Now the ones highlighted in yellow are the ones you're going to use mostly, and I think they're kind of like your main conversions. So I would definitely memorize the ones in yellow. If you notice down here, this is what we just went over in the metric conversion system. Kilogram is 1,000 grams, a gram is 1,000 milligrams, and this shows you if you're going to the right, each of these abbreviations you multiply by 1,000. If you're going to the left, you divide by 1,000. Okay, again, here's more metric. And we'll get to temperature probably a bit later. But here, 1 inch is 2.54 centimeters, so that's going from household measurement to a metric measurement. But definitely the ones in yellow have memorized, and pretty much everything else you can derive from those yellow measurements. So remember, lowercase t or lowercase tsp, those both mean teaspoon. Capital T or a TBSP mean tablespoon. So in order to do the conversions between your household and your metric system, you have to have these memorized. So let's look at a few. So we have 1 teaspoon equals 5 milliliters. 1 teaspoon equals 5 milliliters. So there's 2 conversion factors here. 1 teaspoon to 5 milliliters, or 5 milliliters to 1 teaspoon. So dimensional analysis method, if we are converting, say we have 40 milliliters, and we want to know how many teaspoons that is. We're going to take our 40 milliliters, place it over 1, and we're going to multiply by the conversion factor that has teaspoon on the top, because that's what we are converting to. So the ml abbreviation will cancel, multiply across the top, you get 40 teaspoons, multiply across the bottom, you get 5. 40 divided by 5 is 8. So 40 milliliters is 8 teaspoons. If you had, say, so that's dimensional analysis method. For the proportion method, say we have 6 teaspoons. We want to know how many milliliters that is. So one ratio is going to be 6 teaspoons over unknown number of milliliters. And we're going to set that equal to the conversion factor with the same unit on top. 1 teaspoon is 5 milliliters. So with the proportion method, you remember we cross multiply. So 6 times 5 equals 30. Then we divide by 1 We still get 30. And we're looking for milliliters. So 6 teaspoons equals 30 milliliters. So when you're converting between systems of measure, you have to know your equivalencies. These have to be memorized. You can use dimensional analysis or proportion, or the way I look at it, this is kind of a shortcut dimensional analysis method. Okay? I always memorize my ones on the left. Memorize ones on the left, which most of these have 1 on the left. 1 teaspoon is 5 milliliters. A tablespoon is 15. 1 ounce is 30 milliliters. I would change this to 1 cup equals 8 ounces. 1 cup equals 240 milliliters. So there's actually 2 conversions, 2 equivalencies here. 1 cup equals 8 ounces. 1 cup equals 240 milliliters. So this pound kilogram, I would memorize it as 1 kilogram equals 2.2 pounds. If you memorize your ones on the left, if you are converting from the left unit to the right unit, you're going to multiply by this number in front of the right unit. If you are converting from the right unit to the left unit, you're going to divide by that same number. So if I'm converting teaspoons to milliliters, I'm going to take my number of teaspoons, multiply by 5, and that's going to give me my number of milliliters. If I'm converting from milliliters to teaspoons, I'm going to take my number of milliliters, divide by 5, and that's going to give me my number of teaspoons. So we started out with 40 milliliters. So that's the second one. 40 milliliters, divide by 5, gives me 8 teaspoons. In that second example, we had 6 teaspoons. Multiply by 5, and that gives me 30 milliliters. So as long as you memorize the ones on the left, 1 teaspoon equals 5 milliliters. If you're going from teaspoon to milliliter, you multiply by 5. If you're going from milliliter to teaspoon, you divide by 5. And it works for all of those as long as you memorize your ones on the left. So you can, each one of these again produces 2 conversion factors. You can use dimensional analysis, you can use proportion method, or the multiply divide method, which this multiply divide, that's actually just a shortcut of your proportion method. All right, so let's look at the cup. If I have 1 cup, I have 240 milliliters. So if I'm going from cup to milliliter, I multiply by 240. If I'm going from milliliter to cup, I divide by 240. So say I have a half a cup, and I want to know how many milliliters that is. So if I take 1/2, or we'll write it, now cup is a household measure, so I do not have to write that as a decimal. I could leave it as a fraction. But either way, a half a cup, I would take a half times 240, and that gives me 240 over 2, which equals 120 milliliters. If I wrote 0.5, because 0.5 and a half are the same, times 240, when you do your multiplication, you still get 120 milliliters. If I had 480 milliliters, and I want to know how many cups that is, I would take 480 and divide by 240, and you would see 2 cups. Okay, so let's go over some of these practice questions. So these are household to metric. These are converting between household and metric measurements. So 2 kilograms equals how many pounds? Well, we know 1 kilogram equals 2.2 pounds. So if we're using just the multiplication method, I'm going from kilogram to pound. So I would take kilogram and multiply by 2.2. So that would give me 4.4 pounds. I'll do this first one using all 3 methods. So dimensional analysis method, I have 2 kilograms, place it over 1, and I'm going to multiply it by the conversion factor that has pounds on top, because I'm converting 2 pounds. So I'd put the 2.2 pounds on top and the 1 kilogram on the bottom. So the unit or the label cancels, and when you multiply across the top, you have 2 times 2.2 pounds over 1 times 1. So that's 4.4 over 1, 4.4 pounds over 1, which is just 4.4 pounds. So the proportion method, I'll do the same problem using the proportion method. So 2 kilograms is to how many pounds when I know 1 kilogram is 2.2 pounds. So remember, units match across the top and bottom. Cross multiply, so I have 2 times 2.2, which gives me 4.4, divide by 1, and I still get 4.4. So this is my kind of shortcut multiplication method. Here's the dimensional analysis method. Here's the proportion method. So you do not have to know all 3 methods. You can do these whichever method you prefer. You don't have to. We will never tell you you have to do it a specific way. All right, so 90 milliliters is how many ounces? Well, I know 1 ounce equals 30 milliliters. So if I'm going from ounce to milliliter, I multiply by 30. If I'm going from milliliter to ounce, I divide by 30. Well, here I'm going from 90 milliliters to ounces. So 90 divided by 30 is 3. 90 milliliters is 3 ounces. Tablespoons to milliliters. I know 1 tablespoon, capital T again is tablespoon. 1 tablespoon is 15 milliliters. So if I'm going from tablespoon to milliliter, I multiply by 15. Oops, that's a 1. If I'm going from milliliter to tablespoon, I'll divide by 15. Well, I have 3 tablespoons. So 3 times 15 is 45. So 3 tablespoons is 45 milliliters. Now milliliters to teaspoons. Well, I know 1 teaspoon equals 5 milliliters. So remember, teaspoon is TSP or lowercase t. So if I'm going from teaspoon to milliliter, I multiply by 5. Milliliter to teaspoon, I divide by 5. Well, here I'm going from milliliter to teaspoon. So 25 milliliters, 25 divided by 5 is 5. So 25 milliliters is 5 teaspoons. Cups to milliliters, I know 1 cup equals 240 milliliters. Going from cup to milliliter, I multiply by 240. So 2 cups is 2 times 240, which is 480 milliliters. Same conversion. Now I'm going from milliliter to cup, so I divide by 240. So if I have 120 milliliters, 120 divided by 240 is going to give me 0.5 cups. Okay, so using all of these, there's no number line you can jump around to. You just have to memorize all those equivalencies. And you have 3 different methods. It's up to you which method you use. You don't have to know all 3. Pick the one that you like most, that you understand most, that you're more comfortable with. Okay, so the next thing we want to talk about is, what if there's no direct conversion? Meaning you don't have a direct conversion factor. You don't have an equivalency. So if we're going from pounds to grams, if you look at this sheet, there is nowhere it's going to tell you how many pounds equals how many grams, or how many grams equals how many pounds. So if there's no direct conversion, you have to kind of put your critical thinking cap on. If I'm going from pounds to grams, 11 pounds equals how many grams? I don't have a direct conversion from pound to gram. Is there anything I can convert to that I could then convert to grams? Well, if we look on our handy dandy conversion sheet, I can go from pounds to kilograms. And my metric conversions, if you remember your table, you can go from kilogram to gram. So you can kind of think of it as a double conversion. I'm going to go from 11 pounds to its equivalent number of kilograms using the 1 kilogram is 2.2 pounds equivalence. Then once I'm in kilograms, I'm going to convert it to grams, either using your metric number line or the 1 kilogram equals 1,000 grams equivalence. So I'm going to go from pound to kilogram and then from kilogram to gram. So I know 1 kilogram equals 2.2 pounds. I have 11 pounds. So to convert that to kilograms, I'm going in this direction. So I have to divide by 2.2. 11 divided by 2.2, I think it's 11 divided by 2.2 is 5. So 11 pounds is 5 kilograms. Now I have to go from 5 kilograms to grams. And if you remember your line, kilogram was here, gram was here, and there were 2 lines between it. So to go from kilogram to gram, you're going to move your decimal 1, 2, 3 places. So 5 kilograms, 1, 2, 3, is 5,000 grams. So you have to look out for those. Sometimes you might need to do a double conversion. If there's no direct conversion from what you have to what you're converting to, you have to ask yourself, is there an in-between conversion? So I couldn't go from pounds directly to grams, but I went from pounds to kilograms to grams. So the last system of measure we're going to go over is the apothecary system. Apothecary is just a very old system. It's barely used, but you will see it here and there. You may never see it, but I have talked to some nurses that have seen some things in the apothecary system. If you notice, ounce and pound are both used in our household system. So these pieces were basically absorbed into the household system. In this class, the only part of the apothecary system we're going to use is grain. We're going to do some conversions with grains. So, you can use a clock. Think about 60 minutes in an hour to help you with your conversions with grains. Normally, 1 grain is equal to 60 milligrams. There are 3 instances where 1 grain is equal to 65 milligrams. And in this class, it will specifically say Tylenol, iron, or aspirin. And if it doesn't refer to any of these, it'll say convert, grains to milligrams, and it is not Tylenol, iron, or aspirin. So you'll know whether to use 60 or 65. But with the 1 grain equals 60 milligrams, if you think about it as minutes, 1 grain is 60, 1 hour is 60 minutes, a quarter grain is 15 milligrams, a quarter of an hour is 15 minutes, half a grain is 30 milligrams, just like half an hour is 30 minutes, 3/4 of a grain is 45 milligrams, just like 3/4 of an hour is 45 minutes. So this is just a visual that'll help you convert your grains and your fractions of grains to milligrams. Now you don't want to confuse grain and gram. The apothecary grain is abbreviated GR, lowercase g, lowercase r. But our metric gram is abbreviated with a G, and again, sometimes GM, but I don't use it in this class, and I've not seen it used. So GR for grain, G for gram. Also with grains, they use Roman numerals instead of decimals. And you will see Appendix A in your textbook has a listing of Roman numerals. If you don't know how to read them, you can go to this page. Well, this might be from the old edition of your book, so it might not be page 598, but it'll be somewhere around there. So if you see, sometimes some of your orders will have Roman numerals and GR, so that means grains, and you have to be able to convert that to milligrams. So we use fractions. If they're not Roman numerals, you'll use fractions instead of decimals. Use GR for grain and OZ for ounce, but like I said, ounce is now household, so we use the OZ anyway. One other difference with grain, the unit label comes before the number. So you would have your label first and then a Roman numeral indicating how many of those grains. So this slide shows you the Roman numerals you should know for this class. The only fraction you have to know is SS. SS is a half. So your I's are always ones. So you start out with 1 I, 2 I, 3 I. So that's 1, 2, 3. Now, 5 is represented by the letter V. If a smaller number comes before it, it's subtraction. So IV you can think of as 5 minus 1 is 4. If the smaller number comes after it, it's addition. So VI is 5 plus 1, which is 6. VII is 5 plus 2, which is 7. 5 plus 3, which is 8. 10 is X. IX then would be 10 minus 1, which is 9. XI is 10 plus 1, 11. 10 plus 2 is 12. 10 plus 3 is 13. Now we have X, I, V. So the I is smaller than the V. So that would be 1 from 5, which is 4. But 4 is smaller than X, so it's X plus 4. So XIV is 14, XV is 15. So these you should know definitely 1 through 15, and know that SS is 1/2. So how would you notate 4 grains? Well, we know the Roman numeral 4 is IV. The abbreviation for grain is GR. And remember, when you're using Roman numbers, the abbreviation comes before the number. So it would be GRIV, or in English, we would just say 4 grains. Now, 2.5. In Roman numbers, we'd have GR. We would have the number for 2 and the number for half. So it'd be GRIISS, or 2.5 as a mixed number and grains. So you're not going to see a ton of this in this class, but you will most likely see a couple on a homework, a couple on a focused review, one, maybe 2 on a quiz, 1, maybe 2 on your final. So you probably won't get a lot of practice with it, but make sure you practice it here and there because you will see it on a quiz and on a final. So that is pretty much the gist of the week 3 material. I hope this video helps.